All right, guys, I'm going to be doing a little video here to get you guys a little bit more practice and familiarity with when the different trig ratios are positive and when they're negative. So we're going to go back to this Desmos graph that we have here of our unit circle, and I'm going to hit play on the point that's going around the unit circle. And we don't necessarily know what that point is at any specific time, but we do know that we would represent it with an ordered pair x, y. So wherever it is at any given point, we would say that, like for instance, if it was here, we would say that we could represent that point with the ordered pair x, y, since we don't know what that point is necessarily. The other thing that we would say is we don't know this angle, but we do know that if we were to find that angle, we would have to at least identify that we don't know this side, it's y, and we don't know the length of this side, it's whatever x is at that point in time. So wherever we are in our unit circle, we can at least identify that our cosine values are going to be related to x, and sine of theta is whatever y is. The question is, what happens when this triangle moves to different quadrants? So let me clear those. And let's hit play on this. All right, it's going to keep moving around. And what we notice is now that it's moved into the second quadrant, something has changed. Specifically, our x values in this quadrant are negative. So if we were to identify the length of these segments now, that would be negative x. This doesn't really change. This is still just y. So if we were to set up this ordered pair, it would be negative x and y. X would be negative, right? Depending on whatever x was in the other quadrant. So what we've noticed now is that, and we know from class that cosine of theta is x. In this quadrant, cosine is negative. And since tangent is going to be y over x, and that x is negative, tangent is also negative. So the only thing positive in this quadrant is going to be sine. And since it has a reciprocal function of cosecant, we can say that cosecant theta is also positive in that quadrant. So I'm going to be labeling the things that are positive in each of the quadrants. Now let's hit play. And that triangle keeps moving around. Nothing's changed. So far, still the y values are the only positive ones. And now we cross over into quadrant 3. Now that we're in quadrant 3, the x values are still negative, so cosine is negative. And now the y values are also negative, so those are both negative. But since tangent is y over x, when you divide a negative by a negative, you end up with a positive. So actually, tangent of theta is positive, and its reciprocal, cotangent of theta, is also positive in quadrant 3. All right, let's keep moving. As that triangle makes its way over into quadrant 4, our y values are still negative, but we notice that our x values now are positive. So since x is associated with cosine of theta, we can say that cosine of theta is the only positive trig function, along with its reciprocal, which is secant theta. So what about quadrant 1? Well, quadrant 1 is the only quadrant that's special in that all of our values are positive in this quadrant. Whatever x is positive. Whatever y is positive. So sine and cosine are both positive, and when you divide a positive value by a positive value, you get a positive value. So tangent is as well. So not only are all these values positive, but their reciprocals are as well. So we can say that all of our trig functions are positive in quadrant 1. And you can use this on the bottom section of the homework for number 3. All right, so hopefully this is another good little tutorial on how this works and how to find the sign of each trig function in the different quadrants. Okay, good luck, guys. I'll see you tomorrow.